Okay. Then I can take
Okay.
Okay, let me call you again. Sorry, just to be sure, you know. Because there are certain rules. We have only say 24 people including us. We need to send back one person. Yes. Okay, welcome again. And so, since I would like to take first here. He will come back here, but first, let's start from this. Yes, we will get on here. This is actually important for us. We have to offer this CMS number. So why? Because we have lots of reasons. But the first thing that CMS is the only detector, as you have already heard in the video, that was built in by different countries in different places, and that was rolling here starting from 2007 or end of 2006, beginning of 2007. And the sections were brought here. The small pieces, the small sections were lowering down here. This is called small shaft, and there is another one, big shaft, that we'll be seeing. We will be doing these things actually. So the thing that we have put everything under the ground, and the assembly was done under the ground. So as Barun already said that we will be going about minus 87.9 meter. This is the only place, this is the only level that the visitors are allowed to. The detector is placed on 97 to 100 meters under the ground. So just to give you an idea how far, okay, you will not see anything for sure, it's close, but to give you a feeling that how further down the detector is placed. So this is the starting point. And afterwards I would like to take you way over the way. There is a battery, right?
You are facing here, and could you please look at the left side? There are how many people working inside the CMS? You can see. Yes, the whole name writing is here, and from which country, which institute, and more people, of course, and the 3,000 people working in CMS, only CMS, in not the SR, only CMS, 3,000 people from different country, different culture, different, all of them different. But we together the working. Birlikte çalışıyoruz. Hep birlikte 3000 kişi. Yes. Together. Excuse me.
Yes.
Be careful.
Anyway, but is a simulation. This is how it looks like. So now this is the real ones actually. This is how, but you can see that the CMS experiment at LHC, and it was recorded in 2012, May 13. This is the real one, the real event that you can see here. And the rest is the real pictures of the CMS therapy. And yes, you would be here during the Christmas time or beginning of the year, not Christmas time, I apologize, it's your holiday. You would be here and you could look at the decoration. This is the closed format. Did I answer your question? Yes. Okay, now.
No.
So that's a visitor's place. Inside will use another way. That's a special door. There is a small machine that can read our retina. And in order to be able to guess, our visitors are only allowed to go this way. So we have a key for you. And when we are inside, we will open the door for you and then you will come inside. And there.
I will press it.
Okay. So this one is actually a dosimeter. What it means is you can imagine that there's a radiated area. Well, it's not effective, but due to the safety reasons, we have to always check this. Actually, this is a kind of a Geiger counter where you can really count the number of alpha, beta, and gamma particles. And so all information is written here, and it's taking, and we have to make it every month. There's a machine, small machine over there, and we have to send our data with that machine. Okay, sometimes it doesn't work.
Why? Because I haven't been.
Go and take your helmets.
I forgot to buy a helmet.
I will be taking you to the left side, and if there is still left, I will give you earnets and also visitor's helmet. Okay? So now I will make myself.
That's really the VC shit. Right there. You'll have to pull the eye out. Yeah. Yeah, you see, it's starting already feeling more too, right? Yes, I'm So,
No, and then we, of course, we having. You haven't did any helmet.
okay, there is no airnets left over, sorry for that. Oh, okay, so we will just give you
For you.
please take one and pass.
Why?
And
Why is it change? Yes, give me the light speed. That.
secrets, very secrets. I'm just going to say everybody.
Oh,
Service names for please. Please say one and pass.
Okay, all of them. Perfect.
This is too tight or this is too loose. Yeah.
Perfect. Also,
We will not be able to take you very close to the place. Now we have some comfort. Yeah, you will feel it.
no, is that right? Look, yeah, okay, maybe little bit.
Have more. At this point,
Yes, okay. If you have a helmet,
Yes. Okay.
come here.
Yeah. Okay.
If you have helmet,
It's not really working. I will take.
you have a special helmet. Why is special? Because there are a very special chip inside each helmet. This chip and also we use some kind of detector. Detectors count you one by one. This detector is here.
Oh, cool.
Yeah. Why? Because it's very special. It's a safety. How many people come down? How many people come here?
Is this a mountain?
Yes, the count is a detector. The detector is the count for your hand, of course, another one that is special.
So,
There are inside the chip.
yeah, there's a chip inside and there's a sensor. So, before we go inside the elevator, I would like to remind you one thing. In case of any emergency alarm. So, it can happen, sometimes it happens, it's very rarely happens, but it can happen. Please stay calm and follow us. And there's an assembly point. When we go down on the ground, you will be seeing that. There's a pressurized area. And it's the only thing that we are allowed to use the elevator. It's opposite to the daily life, right? So in daily life, you are not allowed to take the elevators, but the stairs here the other way around. This is the only way that you are allowed to go up in case of any emergency. So now please come inside.
So in case of emergencies, use the elevators.
Yes.
Yes.
At first, come to the assembly point, and then afterwards take the elevator. Together, all together.
We need to take the elevator.
But we never see any problem. We never see.
I hope you will not see us.
Okay, little bit
Guys, look at
stress.
me.
Okay.
Now look at here, by the way. You can,
Yeah, it is important
so,
why. How can
just to make you to have a look at it. So in about even you can make it
Hey,
87.9 meter. This is the exact.
you come here?
So I was explaining one lady that the first floor, which is higher than this, so -1 is only for the experts, or if there is some problem happens for subdetectors. So we have readouts over there, and we can go and check immediately and to do some reactions, let's say. So do I need to talk about a little bit CMS? Yes, I think. Well, you know it better than me probably. Compact muon solenoid. Why it is compact? Why it is muon? Why it is solenoid? So it is compact. Again, we are proud. You may remember that I wanna tell you that why I am proud to be a CMS member. This is the second thing. It's a compact. I don't know if you have seen already the Atlas Expert, yes, but yeah, good, very good. So it's a wider, it has a big volume, but when you compare the weight, the mass of the CMS is 1.5 times higher than what the Atlas has actually. So you have already heard that it's 14,000 tons. We started with 12,500 tons
So
in
better than-
2010. Well, yes, better. Well, we had to change many things. Like, we can be proud. Yes, we have a better.
But you can start to think about why it's different detectors.
Yeah.
How many hits?
Yes. The same mix.
Well,
Different people's, different detectors, different signs.
so
but
there's a
two
question. So when you look at the LHC, maybe we can go inside and
Yes,
we can talk
why
about
not?
there.
Okay, why is the
yes,
pool?
so
Is the big
all
one?
the
What
doors
is the
and-
protect
Yes,
all of the
the
safety?
doors. Right. Yes. Here you can go. Well, that's my
You can. Now and we are in H-8 with and under this big door and there are the detector holes. Yeah.
How much?
I cannot begin now, but because we have a very big wall and we don't want to affect the radiation to the about the safety
Yeah.
issue.
Oh, no, I think we're coming together.
Yeah, okay, maybe I cannot do it.
So, while you are here, well, that's, okay, let me start from the bottom actually. The detector is placed on the bottom. There's a wall that you cannot see at the moment. We have a 7 meters of thickness of the wall.
7 meters.
Thank you. So these are just these are the LED lights. And just to point out that the collisions are happening over there, just in the middle, the center, the heart of the detector. Just we are pointing out. We want to make excited our visitors, or sometimes, you know, we have small visitors like 10, 12 years old, so they think that this is proton and they are going up, and so they can have lots of imagination. So I would like you to have a look at behind the pictures. These are the nice pictures. I know that you have seen some of them in the video, but I would like to again emphasize some of these which made me, you know, excited, and I hope it will be. So there was nothing. We started in 1999. It was a field. So during the excavation time, so you can see some pictures, we have found some leftovers from the Roman Empire, and these are now available in the Geneva, in the Geneva. Okay, where are you now? Okay, what I was telling you, if you were here, beginning of the year, so we call it end of year technical stuff, we had a time of like 3 months or so. So you would be here in the first one. Actually, we're not here, but we're not in science. So and there was nothing. So that's the camera where we place our detector. This is a big shop, and here are some pictures that I would like to show you how we were lowering down the pieces of the detector. So the compact we need to talk about. I haven't forgot yet because we have to still start to think about what is compact. It's 40,000. It's a compact, but what about mu? So muon is a particle, as you know well, and if you compare the mass of that particle, it's 100 times higher than what the electron has actually. Why it is important? Well, it is important because what we are doing, we want to try to understand what happened during the first seconds of, or first moments of the creation of the universe, right? So we have lots of questions. Why it happened? What happened during that time? And many, many questions. Or these are very simple questions that made us to think about it, and that's why we have a detector like that. And muon is one of the particles that can give us some information about the first seconds, maybe less than a second. It's a stopworm. That's how I am calling it. Why it is stopworm? This is heavy, and it's not easy to detect it because it's really not interacting with the whole part of the detector. It can go through. What you need to do, you need to be more smart and more powerful to stop that detector. So the detector is a 3D camera, but also it's a kind of a stopper. You use different kind of stoppers for each sub-detectors. So, and depending on the particle's identity, so it's like the character of the particle, you have different identification methods, right? You use different sub-detectors, trackers, electromagnetic calorimeter, hadronic calorimeter, outermost part, we are having muon stopper, muon chambers. In other words, iron radios. Where is that?
The structure of the iron is here.
Yeah, that's the iron. But I would like to also show you one thing. That I would like to show you muon chambers, real pictures. Well, this one actually you have seen already on out. And that one is also, you see how it is like. So you are here now in France, Cessy. It's a small village in France. You were here already in the reception, and you have been already in the atlas. So we have actually here under the LHC, we have 8 points of experiments. Sorry, we have more than 8 actually. I think we have 12 or 14 experiments. These are the big ones. So CMS and the atlas are having the general purpose detectors. Alice and LHCb are having more specific questions like working on the weak quarks, and Alice is like having ion collisions. that you can get more information. Again, of course, it's looking what is happening, or what happens during the creation of the universe. So we are calling, this is a point 1, this is point 5, I think point 4 and 3, and the rest is like, we have 8 points, and here we have access to the beam, although we don't have any selectors there, exactly there. So, we explain compact, we explain neon and not solenoid. Why the solenoid? Solenoid is actually providing us a magnetic field. Again, we are very much proud to build the strongest magnetic field ever built in particle detectors. So, and it provides us 3.8 Tesla. I know that you know what it is, but just to give you more example about the daily life. So the Earth is applying to us gravity thanks to that we are not flying away. And if I compare what our lovely solenoid, which you see that the first picture, one of the first pictures when it was lowered down here, is applying 100,000 times more, much more stronger magnetic field what the Earth is applying to me now. Okay, so it has 6 meters of diameter. It's actually the biggest part, the heaviest part of the detector. It's about 2,000 tons. And when it was lowered down, it was like this. And this is a very nice picture of how we were lowering down these pieces of the detector.
Maybe we can see in here and all the CMS part and display and surface side. After the complete the installation and the whole surface.
So Salim was the keys one actually.
When I was the PhD student
Yes.
20 years ago, and we worked at the two installation, especially I'm working in a small part on the CMS.
So
My
this
PhD, yes, my PhD is interested in this detector and another.
and harmonic forward calorimeters. Yes.
But,
So,
yeah, another important
one important thing that afterwards, when we are done
Yes.
with the circuits and cabling and how it looks like. So I think you have already heard that we have 75 million of channels, individual channels that we are taking readout from each subdetector. This is really great engineering. And this is another picture that you can have a look. This is an amazing one. How it looks like in the LAT tunnel, our detector. You need to make something little like this. This is also a nice picture. And okay.
Let's go to the
Yeah,
outside.
yes.
Yeah.
If you don't have, okay, let me ask you if you have any question. You are very much welcome. Just a moment, side, please.
Yes.
No one, okay. Okay, so in the inside, it's going to be a bit chilly.
The magnet was the magnet was completely brought here, was not assembled
Sorry.
here.
Yes, yes,
It was the magnet.
yes.
It came, was not assembled here. It was just transported.
Assembly was done underground. Installation was done on surface. Yes.
Installation on surface.
Yes.
Okay.
It was like this, and then we lowered down, and then
It was assembled on
assembly-
surface.
Exactly.
No, but the magnet itself was assembled on surface.
Yes, surface.
Yes,
Yes, we
yes,
selected
yes.
the
Yes,
surface.
exactly.
It's a very big part.
It didn't come by truck. No.
No, okay, I can show you.
Very good. Very good.
Yeah, very good. He knows better than me here.
Okay. Yes, here. Yes.
Yes, you can come closer
Yes,
this
there
part.
is the part of the whole the CMS, and you can see this part.
Yeah.
Yeah, okay.
The part here, pump.
Yeah,
Yeah.
big pump, the same hardware job. Yeah. So, sorry. Yeah.
Any other questions? What is that? It's just a lights, LED lights, nothing else.
No.
Just to show you that, point you that the collisions are happening just inside the detector. It's in the middle of the detector, and that is there. So the detector is sitting just over there, and it's the middle. Not only that. Well, so this is a very good question. The question is like that. How are you cooling? Are you cooling only the supermagnet? No. We have to cool down the whole subdetectors, as I was telling you, because each of them have electronic circuits and many things inside. inside. So sensors, PMPs, silicon PMPs, fibers, and so on. You have to cool down each of the electrodes. Okay?
All the way to.
Exactly. Yes. And now we are changing our way. Maybe I can tell you up here.
Yeah.
So, okay. In the inside, so we will be taking it to the inside. It's going to be chilly, not cold, and it's going to be noisy because of the electronics, and we have to cool down. We would like you to stay on the right hand side. Please follow Sally. It's going to be very cool for you.
To the detector, magnetic, to the solenoid, I don't know. But I suppose, what do you think? What do you think, Luther? I measure with 10 volt increase in the magnetic.
There are the more cables. Why? Because we use more channels inside the detector. Also, we need signal cable, power cable, and any link the cables. We need the more cables for the detectors. We would like to protect the detectors. Here is the detector safety system. You can see, and there are the more and the counting for any and voltage another one.
So actually, the network is sitting over that wall that we can see now, right?
Yes.
Sitting over there. And we need to get information, which means that we need to read out all subdirectors. Since it's a kind of a 3D camera, and we want to take the readout, that means electrons. Actually, what we are getting from the electrons is just an electrons, 1 or 0. So what you do, you just be sure that all your detectors, the subdetectors are giving you the right or good signals. So how you can check this? Well, we know from the labs, we just need to measure the current, see the current, or the voltmeter, voltage. So you need an ampermeter or voltmeter or multimeter. So here they are. So we are just taking out all the information, and that we know that all subdetectors are safe, and we can get the signal. So once I am sure that my detector is giving me the signals, then I can go further and start to take the tape. Please. So if you have any questions, please. Now, you see that this is the power supply detector detail, and here are the numbers. So these are the subdetectors: electromagnetic calorimeter, data acquisition system, tracker. So these are all the information that we can get from each subdetector. And there are contact numbers. So we have experts. Of course, it's a big detector, and not everybody or one person can know everything about the CMS detector. So everybody has his or her own experience. Like on the inside, we are working for handling calorimeter. It's my expertise, but there are some people working for what? Like companies. These are the people that you can contact in case of any incomes of tracker or data acquisition or so on. Okay? And we have technicians by the way also, not only physicists but also technicians are there. Any other questions? So let me
Data acquisition.
data acquisition. So this is all we are sure that we have a safe signals and not trying to take the electron, but not take the data and how we are doing that. So photons are colliding, right? And these collisions happen in every 25 nanoseconds, and every these 25 nanoseconds we have billions of collisions. Of course, you can think like that, very simple things. So you, the detector, CMS detector is like a 3D camera. you could take the pictures every single corrosion that is happening. It's possible. You can get the information. But one of the things that you are limited by the storage. You don't have enough storage to store them. Second thing, not all of those corrosions are interesting for you. So you need to be more selective and more smart to select these interesting events. And coming good thanks to our trigger. So trigger, CMS has two steps of trigger, which is, what is that actually mean? In the first step, out of billions, every second, it's eliminating some of the events that are not interesting. Interesting means that like PT code, energy code, endo code, or something like physics side. That's it about it. And so it has a loose, cuts, and this is called level 1 trigger. It has a more criteria. Then all the billions who are ending at 100,000 events per second, still limited. So we have another second step, we call it high level trigger. And this high level trigger has a more top criteria than ending up like out of 100,000, we are ending 1,000 events. Well, this data is temporarily stored here, and what we do, so the data acquisition is doing their job, and we are taking it and then sending to the, there is a data center in the CERN campus, maybe you have seen it already. So it's sent there, and then there is another second way of, elimination is done, and out of billions of events, we are ending 100 events per second. So we are storing them. So, well, if you think about the running period, starting from beginning of April, ending of end of October, if you run, yes, end of November, including the heavy Iona, end of November, it's about 8 months or so, we are having 5 to 6 petabytes yearly data. So, and then all these data are distributed all over the world and thanks to grids and computer farms that we can distribute those data, and you can sit home and with your laptop you can analyze the data. Of course, you need to be a member of the CMS or one of the experiments working at CERN. Yes, yes. Cool down. There was a question already asked to you, right? Yes. The cooling down. Okay. We have for each simulator we are cooling down, and we are using liquid garbage for the sample, and we are also using sometimes partners or some inside the pipe. Where the electrons are going through this right. This is also our cooling system, and liquid garbage helps us. And I can write the nitrogen we are using this a lot.
I was thinking about this place right here.
Well, these are the it's an electronics and you need effective AC. There's an AC. Yes, it's like that, and you can feel it, right? Data storage center. Whoa, it's not here. Up. Yeah, -1. It's -1. Where is this data storage?
Of course, data storage, of course, is not the whole of them is here.
Yes,
And the
yes.
first one is here, another one, another
Yeah.
building inside the main side. Yes, of course.
We call it CMS
we,
data center.
yeah, this is the first, and the stage 0, because there are the 4 levels of the data storage. 0 is around and the CERN, and the 1 is also, we have another country, for example, like Germany, Turkey, also another level. Also your companies have more data centers. We send data. After the video, of course.
Sometimes
Yeah, of course. Now,
some other
Very early in
also
we
we
have
use
one or two, we have a couple of
the grid
more
and
criteria.
they of the grid,
And this
but
one
we
is
know
we
the
have
boards
one
here,
level, high level trigger. Well,
and
this
that's
is the
the one.
second and more
And
top
we
criteria.
already used
Lots
in the
of
past the
things
DAS
that
WW.
are here.
We used the grid system. Grid system
Yes.
is when they get all around and the
very
In 25 nanoseconds, which means like every per second we have a 40 million 40 minutes per second. So we are
Yes,
taking
okay,
out
so
information from
yeah,
there.
question. And we use the chamber system, rack system. For example, 4 and the
Well,
one
we are still not that
each
enough, fast.
I see
and we were going to change the part
for each one of the events, select one. Because we have enough space. For example, like in the camera, you take the camera, you collect them. Yes.
People went inside the temple, there were some people.
Then you still have to go down.
No, it's not down. I can't see it. It's down.
Then it goes down to the
Yes. On the left hand side, you go inside, and still you are not, you will not be able to see. But there's another door that you have seen where the inside was happening. There's a special door.
This
We have taken the blue grade. And for like 12 meters or 10 meters or so. You could be the first floor where the visitors are allowed to see. So, and that's the whole thing.
Very tall.
Here that place you have.
Yes, yes, of course, because we have yes, you can reach the at the point your house directly to reach the data.
I thought I like it before actually, but I wonder, how do you know that there's something out there? I got unexpected, there was lots.
Okay, if you would like to do the analysis data, of course, we have the some permission to reach on the data. For example, we have already used the Unix system inside the server, and the name is LX Plus. And the first of all, you have to have the account, some kind of account in the server that you have. Oh, okay, I see that. You already used that, and you use them from the LX Plus to reach in the data. To use some kind of
red door. It's a red door.
I'm not sure if you can see there. Yes.
So what was it all about? We didn't hear anything.
What do you want? Okay. So the LAC tunnel is over there. Okay. The red door. And on the right hand side, I was just telling about the safety things, right? So safety is very important. On the left hand side, there's a closet. The red closet that you can find a cell, well, in case of any emergency, there are equipments over there. And there is a door where there is a sign, radiative sources sign, and also there's an alarm, and there's an unconscious person in case of any oxygen deficiency, like about 20%, it's going to alarm. So this is the place. Here the summary is the safety is the most important thing. So if you were here during the beginning of this year, let's say, we would be able to go inside, like 3-4 meters further on the left hand side, and we could take the door where I was showing you when we were taking the elevator, right? Me and Salim was entering in a special door with the retina control. We could be able to take it inside, and you could be able to see the director sitting over there. So that was the whole information.
Okay.
Yes, everybody's done with picturing them. Yes. Okay, it's control from the control. And of course. And there's a machine. Control. And there's a floor. And it's
Just 10 francs, guys. Thank you. Look. Model.
That's just an example. That's the number of this guy. In case of big problem, it's going to be right? So this is the whole supply director detail. And each subdirector has his own expert report. Like, for example, PSI, weeks ago, we were exposed 7 days, 24 hours, in case of anything happening, we were on the call, and we were we were making some checks on the computer and so on. Yeah, we have, well, safety people, like visiting people, doing safety, and everybody has his own responsibilities, and every day, every night, we have a person who speaks like that. 24/7. Yes, yes. And what, well, we shouldn't say the hour, but always there's a person or you, expert on call, that you can contact, because we are taking data over there. There's a controller. We are monitoring everything. What's going on? Yes, we have a shift crew. So because, well, we are not, we should tell the others as well. This information is important for them. What this stands for? I don't know exactly. It's not my business. I know that this is the responsibility for these guys. And this is the rack. Like you see, I think these are the pixels, CSC, high voltage. So you can see that. Yes. I think we don't have enough time, and let's go back up, because we would like our friends to come, the other group come here. Yes. I know that you don't want to go from here. It's cool, right? Thank you so much. You're welcome.
You're like a spy. You stopped writing meanwhile.
I'm writing getting my phone because all people ask me what I'm doing.
And it's just if the battery of your phone just dies, then you need to use the paper. I mean, if the battery will be empty of your smartphone. Yes. Or is it impossible inside?
It's not comparable. It's 25 for me. Yes, please come inside. You can temperature and this.
Yeah, okay, you cleaning, but it's not good.
Okay.
Yeah, it's not more enough. Clean your shoes.
So if you are not, I'm going to open the door and you're going to reach the gate. It's not minus 0. It's showing that we are 0. But when it's pulled down, it says 0. Minus 0.1. It's just a convention. Exactly. Okay. So everybody's out. Okay. Wait for us, please.
It's okay, I am here.
So about radioactive, does it make it longer? I don't like it.
please.
Okay.
Another one that is situated inside, it's situated and shining. Yeah, okay. We taking more and the signal. After that, we use. Yeah, this is the materials for the old color materials, very heavy. Another one is the solenoid side, and you can see here maybe the detail inside the detail shop roof, and this is the solenoid one. So yeah, this is where the liquid. Yeah, yeah. No, it's not the liquid. This is the spare contact. Yeah, yeah. Yeah, the cooling system is here. Oh. Yes, of course. The cooling and the cooling system. Yeah, okay. Also, you can touch and how this square polymeter. Which ones are the cooling
I don't think that is strong here, right?
But
No, I don't think that.
where does the helium go?
Not over the nickel, sorry. Yeah. Yeah, but it was not enough to my, yeah, okay, please.
Also entertaining place I was telling you, right? So you can you were under the door and sitting in the first floor, the visiting place, and you would be able to see wow. This is a good example. I would actually
So nice to push the buttons. It's so nice to push the buttons. What is this? Photon.
Put your two fingers here and the other one by one. Go like that.
Neutral hadron.
It's so. Well, it's inside.
Uh-huh.
It's inside and you will not be able to see.
Charged hadron.
And then go on.
Neutral hadron.
Panther, please.
Photon.
Yes, go on. Okay, so then
And now
wait,
is
wait, wait. One
electron.
by one.
Electron. Electron is the small one there.
And then go to electromagnetic
Se on
calorimeter.
muon, se peab läbi minema. Oh, muon läheb läbi.
Yes. Go on. And now hadronic
See on
calorimeter.
Castor.
Wait a second. And then et voilà, muon system.
Ah,
Now, actually,
Castor lendab
hold
siin.
the hands on, right? No, put everything here, please. Then you will be seeing that all the liquor, when there is a really very, and when there is a collision and photons are smashing here. No, still not, no. Go, Neon system. Yes, it has to switch. Yes, now okay. Now please leave your hands. Move your hands, excuse me. And start from here to see how each particle identification done by which detector. So you can just check what is that? You see the neon is going through from the beginning, the first corrosion interaction point, and afterwards with the pixel, tractor, electromagnetical, hydraulic calorimeter, and afterwards the neon chambers. Yeah? And then what is which one is that? One by what is that? Please. It's an electron, yes. You will be seeing inside. This is small, it has to be stopped. Well, it is leaving the tracks in the pixel detector, and of course it is also stopped by the electromagnetic calorimeter. Go please. What is that? Hadron, it's like protons, neutrons, kaons, pions. These are the neutron particles, hadron particles, hadrons. And then neutral hadrons. Well, yeah, the other one was the charge and the other ones. And what that one? Photons, yes. You see, in the electromagnetic calorimeter, there's a energy occupancy. Let's see.
The best one is the new one.
Yeah. Okay.
What is that castor?
Okay, castor. Very good question. This is a forward detector which was running in the first run period and the second run period. It died now. It's died and it's not anymore there. And it was made by Turkey. So we put effort Turkey, Greece, put a lot of effort on that. Person power, money power, everything. And Belgium. So it was running for the whole run 1 and run 2. Now it's not anymore running. It's a special detector that what one could get information about the forward physics part. So we have been working there as well.
And this is also a detector,
Totem
right?
now. Totem is this detector that you can see that. So it is like how many meters? Like totem is placed about 100 meters further from the interaction point. Totem, it's also a forward detector where when the protons are, when the protons are escaping, not interacting to each other, they could escape, and totem is trying to catch those protons. Some of them are intact. Intact means that they don't interact with the other protons and they are catched here. So these are the special detectors that are aiming to work on the forward physics. Okay, so I think we can go to here. My room and started to please come here. Sorry. Yes, please follow me. Here, how much can you reach with your hands?
No, I won't do it.
No. Well, we could do it.
Also, you are the over. Yes, it's my group. You are the my group.
Oh my god.
You gotta tell them.
Be careful, s'il vous plaît. It's okay now. Let's go.
We would like you to have a look at the pictures. These are the pictures that were taken in 2010 in People's Day, April, March 2010. Just to give you an idea how big collaboration we have actually, but this is just some of them. Unfortunately, I mean, you can't imagine, right?
What is this?
It's all these ones. Like it's CMS.
Okay.
The background.
You can follow the days.
Okay, this is just a video of the correlation part. And we would like to have a look behind. Yeah. Another way of telling you that.
What's another thing?
Okay, now I'm back here. Okay, do not consider the time now because the watches are not working.
No, they're not.
As you can see, the clocks are not working. But to give you the impression. So, we are here and in different time zones in different parts of the world, and there are papers, you can see that, which part of the world, which countries, which institutes are putting effort here. Effort means money, brain, really. So these three things. And the idea to show you actually, I should emphasize, we still have a couple of institutes missing here because we already have new members, right? So, we have a couple of more actually. Why we are showing this? I think this is very important. Science is above the politics and everything. And why we are here, we would like to find out the solutions for many questions that we have in mind as a human being, right? And I would not be, if I am a very rich person, I would not be able to do it by myself. Even I am the richest person in the world. I cannot do it with my friends, with my institute, with my country. That's why we are here. And that's why, thanks to the whole countries who are putting efforts in all ways. And Science for Peace, this is the place that what we are trying to do actually. Plus 2. Well, it means that third is, it means that like it means that 2 hours further and 3 hours further, if I yes, right? Okay. Or 6 hours behind us. So that's 8 hours. Yes. And I think United States, Russia, Japan, these are the observer countries, but they are putting a lot of effort. And means that putting lots of money to serve. And there are lots of different countries having different positions like membership, associate membership, what else? One thing that before I don't remember. Non-member states observers. Okay. Any questions?
Well, is Russia still working with you?
Russia?
Yeah, with the government.
This is a very good question. We had lots of discussions about that. Russia is still working with us, but it will be finished by...
Russian side is working with us.
Okay, not Russia. Sorry.
My question was the Russian government, not the Russian scientists.
No.
Because the Russian scientists, they can speak if they
working with
want.
us, but
Yes.
government not.
Yes.
Not the government?
No.
No. Then they simply said, did they formally say that?
Well, they didn't say certain side by this to stop the relation because it's a European things and so they stopped this.
Yeah.
But Russian scientists are working with us because we have lots of person power from them.
Yeah.
Yeah.
And lots of them came out of Russia.
Your question?
We
We are on the sea level now.
Yani daha doğrusu 3 aynı anda giriyor ama Engin Aynı'nda mükemmel katkıları var. Yani beni Türkiye'ye geri gönderen Engin Aynı. Yani burada doktora yaparken bana göreceksin, yemin ettim. Türkiye'ye geri gönderen. Denizde ben de o kadar büyüyemedim. Geri dönmeseydi yani burada
Yes, easy to hear.
Exactly.
Science, take them to S65. Science, please take them to the S65.
Another one, okay. We follow, follow me. Go to the S65. See all the sides in S65.
Are we all
So
together?
would you like to join us?
No, I'm okay. I've already done it all. I mean, it's
Okay, as you like. All right. Although you haven't seen the CMS by real eyes, we would like you to see that magnificent picture. This is the real size. And it has 15 meter, no, the height is 15 meter. And you may remember that I was telling you, there's a big shaft. So this floor is a movable one, it's a platform, it's a movable one. And during this end of your technical stuff that I was telling you many times, we are opening it, and in case of anything, so the whole detector is open and everything is open. Right? Exactly. Right? So the detector is really sitting there. You have seen already the pictures, right? So how the detector was lowering down and the big pieces were lowering down from the image.
The brakes are off now. Don't have any brakes.
And brakes, yeah.
They're not. You have to put them again. You put that.
Yeah.
Oh, okay. You
See?
have to put them
The
again.
brake, exactly.
You will have to go there again.
Exactly. So we don't use brakes at the moment. Well, you can see that when we use that, so the CMS was done well, the pieces were done in different countries, and then in 2007 we started to lower down. In 2007 November, and we ended up.
Yeah, okay, 20 years ago when I was the PhD student, I'm working for one. For example, this stage, and you can see some people there still. There are some very small laboratory. The laboratory work and the installation of the old detector part of the part.
The big piece were here, and we were using a special method. You can imagine.
Yeah.
Magnetic field. You can already measure.
No,
it.
it's not magnetic field. I
Which
would
one?
like to emphasize this here. How can the moving and the old detector part, because it's
You are
very
saying that
important and very nice the engineering. It's very flat in the
Because of
like
air.
of the Teflon.
Because of the air,
aircraft.
Yes. So
It is very important.
how is it called? It's like
And surface
Smooth.
is very
It's
flat,
very
very smooth,
smooth. It's flat.
and like a Teflon.
yeah. But we were also using a special material like air underneath of the big pieces of the detector to move it. So it's like making ice skating, right? But of course you have to be very, very careful.
But this is the door. Also, I would like to say that this is door. This one is the door all hole. Yeah, you can see it's the door. Yeah, this is the door is the main thing.
It's a horizontal
and the
door,
whole
not a
door,
vertical
and go to the under the picture.
If it's the right word to say, I tell like a platform, movable platform, that you can open it, and here, so there's a special piece that you can actually open it like that. That's why he's saying door. But yeah. So we would like you to have a look on the left hand side. There's a big map. So the LHC tunnel is. There is going to be a just. No, unfortunately, you should come end of year technical stuff, end of this year, or next beginning of next.
This is the path where they're speaking.
Yes, now we just would like to show you where the electrons are going. Okay, I would like to start from the scratch. So we are taking the protons right from where? Thanks to hydrogen, it's the most exactly, most simplest and also the cheapest that you can find lots of hydrogen, right? So it's easy to strip the electron from the proton in the hydrogen gas. So thanks to electric field, we can strip it, and then we are sending it to the. Here, the idea to show you this picture is actually we are not directly using the protons in the LHC tunnel. They are circulated first of all. They are sent to the linear accelerator, which has a 33-meter long, and we are applying electric field. One more thing. Yes, it's mixing now. Okay. So for 33 meter long, we are applying electric field, but we are using another thing, circular motion. If you have a charged particle, you can force that particle by applying a magnetic field and have a circular motion. And so the protons stripped, sent to the linear accelerator, LINAC, it's 33 meter, and then send it to PS, SPS, different circumference of these circles. And the idea to increase the speed of the protons, in other words, to increase the energy of those protons by using the circular motion. So the protons are gradually increased in the energy, and they are sent to the LHC tunnel. So you have seen in that map, actually, there are collisions happening on the 4 places. On top, you are CMS. The north part is showing the CMS. Now you are here actually. So on the south part, Arctus is placed. On the right-hand side, L is LHC, the left-hand side. So these are the 4 big experiments, detectors that are, having the collisions. That's the idea to show you. And one thing. Okay, maybe I can let
Yeah, okay.
You can explain to everyone.
Yeah, okay. I tried to explain, and then please again.
Ask your question.
Yeah, repeat your question. Simultaneously. No, I think it's not simultaneously. We have at the same time, and all collision created at the same time because we have the LHC clock. On the clock, say
I
that
don't
yes.
get your question actually. What does this mean, simultaneously?
Simultaneously, for example, when the one collision inside in the CMS and the one different time. No, like this, we have the LHC clock and we get it and the all collision at the same time. Because we have some kind of
Well, you
LHC
can
clock.
have a look at that picture actually, right? So you can make it again. So the protons are prepared and gradually having the energy, PS, SPS now, and afterwards, once they have enough energy, they will be injected into the field. And then, so of course, the question is like that. We don't have only one bunch of the proton. So we have about 2,500 bunches, which means a train. You can think like a train. You have a train, 25,000 of trains, and each of these trains having a 7.5 meter distances. In other words, 25 nanoseconds distances. So, and then, yes, at the same time, we are having the collisions, but not the same train is making question of bunches. So one thing, in each train, let me explain one thing. So we are putting about 10 to 11 protons in each train. So these trains are sitting together and turning over. There is 25 milliseconds, 75 meter. And what else we should say? That's it. Okay.
Here on the map, where is the accelerator part? So where is the electric field?
Nina, this is not shown actually. Well, maybe you can start again.
No, I mean in LHC.
A little bit, yes, that's the started one.
But where is the where's the
Linak is the beginning of the start.
Where is
Linak is the beginning of
only one?
main side, yes.
Only one.
The RF cavity
Only
on
have
the
one.
LHC.
yes.
The whole college field is one way.
Yes, parking lots. Started
That's
on
the only linear accelerator.
yes,
accelerator.
the
And all
first
magnets.
part of the started on the
Wherever they pass there, there's
yes,
That
sorry.
was a very good picture that explained
Yeah, it's a we have
I have a question.
No, you are not allowed. You don't remember? No, that was a very good catch actually. You could see the whole things that instead of showing
Not the
this
detail
one,
is
this
here, but your
details
question,
not-
yes, answers maybe.
You could see that. Yes, please.
Another question. When you started digging the
the
LHC, what about the people? What did the people say? People.
Okay, I
People living
understand.
there, what do they say? Are we?
So
Yeah, we're
let
okay.
me start
you
like
can-
that. So you see
you can
this,
put
how
a
big
particle
this building
accelerator.
is, how big it is. So people around here, they were not happy because we were putting something in front of them that they will not be able to see the Mont Blanc. So
Yeah, exactly.
they, and that's why they couldn't make it even, you know, up even 1 meter, couple of meters up. It's tall.
Were they afraid
Tall,
of?
tall.
Were they afraid of radiation?
Of course.
Were they
But you
afraid
remember-
they might?
okay.
But we not we don't need the really is the 100 meters. It is one. Yes, if you talk about
Yeah.
in the underground.
I mean, the whole
The
thing,
people
the
were
LHC,
afraid because the end of world is coming when we
No,
were
okay.
having the collisions and they didn't send their kids to the
That's because
school
I read,
in the France.
that
the
people were
same.
afraid of black holes
Yes,
that were
yes.
going to happen and destroy the
But not
world.
exactly black holes. Exactly, this is what the people were thinking.
Were there,
Why?
were there demonstrations
And
or anything?
yes, there were not the demonstrations, but the people didn't send their kids to the school. They were afraid.
Of the black holes.
Yes,
Yes,
not the black holes. They didn't say the black hole. The
Yeah.
collision,
Collision, yes,
radiation.
collision.
So
We
they were
expected
thinking
and
that when we started in 2010, the first collision, and they said that okay, this is the end of the world. The whole universe will crash, and then everything will. I don't know how to say.
And then afterwards, did anybody complain? And did anybody come
No.
to you saying, I have this disease because of you?
As far as I know. Okay, very good question. The question answer is like that. CERN is every year in different time of the Paris we are opening our doors to the public. So we call it public
Awareness.
Days.
Something public days, yes, public days. So people could come to here with their kids. They could see all the detectors and what we are doing then. So if you are doing it very regularly, then people now
get to know.
realize that okay, this is not harmful.
Not still not yet.
Still not there, and they were more comfortable. Let's say they were not complaining or they were not afraid of. So
But there were also compensations for people who lost their views of the Mont Blanc. Were there anything? Or
I
were,
think
were
that's
there,
why they lowered and they.
were there for the
didn't-
communities? Were there any things that CERN gave to the communities in terms of I don't know
this is
sports
we
installations?
were just talking about this today. You know, maybe these people went to the court because we were putting something on their view, Mont Blanc view, and probably CERN paid some money.
Okay.
Maybe that's my
Right,
guess.
okay,
But this
cool.
is not not.
No, just
That's my maybe.
Sorry.
Yes, sir.
Someone told us actually that Geneva gave the lands.
the lands, yes, but the people.
Not
talking
everyone.
about the people.
And that's only
Here,
in
for example, I'm
Switzerland,
just
not
talking
France.
about here because we are in France and CMS is living in the France side and people around, so they have houses and they couldn't be able to see the well in Mont Blanc. They were complaining and probably they went to the court. Maybe this is not a official statement. I can tell that was a rumor. I can't say that was.
I have a suggestion. You have this beautiful picture. Maybe take a beautiful picture of Mont Blanc, put it on the outside of the
Yes, I like it.
Oh, and by the way, those
Let's
tubes,
take
they're
a
from
photo
the
now, it's
electron,
done.
proton, electron,
Yeah,
positron
yeah.
on the left. Okay.
And this one is RF cavity. That's the way we use laser technologies, and now we are using that Siemens new technology RF cavities. So just to show you.
The last time I've been here,
No, of course. Just
you take a picture of the.
something Yes, yes.
No, we are not taking out the star. Always there. We are not taking that off.
These sense is done. It's supposed to use. Yeah. Don't go outside because it's close and if you don't go inside.
You would like to use
Finished? Bitti değil mi?
No, not yet.
Is this open for people that are not like programs of teachers or
All people.
yeah, you just have to like scan. Like how difficult is it to
Really, I don't know. Detail, because I'm only the guy.
everyone can do this everyone
Yes, all people see. Sometimes we have the gate and the free reservation. Yeah, it's good.
and is the CMS is the only detector that I can start from.
No, all of the detectors. Yes, of course. Also, sometimes stuff on the Deniz.
So let's take at 4, sure.
No, okay. It's another yeni bir grup var. Sorry, I'm changing in Turkish.
Nina? There's another group?
So you are both from Turkey?
Yes, my wife.
No, she's my wife. That's children.
Yes.
So I would like you to follow me with the silence because there's another group, right? And they're watching video. Please be silent and follow me. I will take you to the pipes place and come back here again to show you the subtitles.
Okay.
Yes, please follow me.
Yes. Yeah. Okay.
What is known as the standard model of particle physics. However, despite decades of correct prediction after correct prediction, physicists know that the standard model does not show its feature. Theorists propose several extensions to the standard model, many which include predictions that can be tested at the LHC and CMS. These include searches for dark matter,
So the quadruple is trying to keep the protons inside the tunnel, not to escape. It's like applying magnetic field, and it's like sit here, don't escape, sit here, don't escape. It's doing like that. And of course, it's not a perfect world. We have some protons, not all protons, that can escape from pipe. This is also counted. We are taking into account. Protons, they are not in interaction. Protons are escaping at the beginning. So these are also counted as an uncertainty for all measurements or all the analysis that we are doing. Yes, okay. That's all. Any questions? No, we are not done. Not done. Here, this part is done. This part is done. This sound always. Yes, it stays always because we are cooling. You are asking about how we are cooling down, and these things are coming from the ground, underground. You know.
You put a new press because it's a little bit
Maybe. Yes, the coming protons are going in the clockwise, the other ones are anti-clockwise. Okay, if we are done here, I would like to take you to the room. This is important because I would like to show some part of the sub-collectors, okay, some demonstrations. Yeah, this is a very nice picture. I like it very much.
Oh, and look at the predicted grade, how well spotted. Yeah.
You can sit down inside.
From the inner side of the vector, we will be going like that to the outer side, innermost and the outermost. So we are starting with the pixel detector. So on the left-hand side, there's this one module that you can see the pixel, and there's a microscope and how it looks like. This is a bigger version. And on the right-hand side, when the circuit is done and the readout is, it's closed circuit, and the readout is also shown here. So the pixel detector is used for the charged particles like electrons and who can leave the tracks. So we are reading the tracks from the pixel. Okay. Yeah, you can come closer and have a look at more.
Like the CCD sensor.
Okay, so I would like you to take more here. So this is a nice picture. First of all, look at how amazing it is. This is the tracker again, but this is the outer part. Look, you should come closer and to have a look at this picture, how it looks like. This is the tracker outer barrel. So how we place the whole tracker here, and these are the readouts. So we have been talking about, you remember how many 75 million individual channels, and this is one of them. This picture is showing. So, actually, on the bottom, there's a one piece of this tracker is shown here. So these are the mirrors when the particle goes through like that. So it's leaving its track, and then we are taking the readouts from each piece of the tracker. So actually, the tracker is giving us coordinates, like X, Y, Z coordinates, the particles coordinates. So we are really reading out the coordinates, the position of the particles. Yes, exactly. So let's come to there. Yes. Now it's yes. I won't. No, don't read it. I will. Don't. This is a secret now. Touch it, please. So I would like you to touch first and look at it, don't read it. Test it together with two hands. Otherwise you can do hands. Yes, two hands. I'm going to vote. Everybody. So which one is heavy? Which one is lighter? So on the left hand side it's heavy, and the other one. But when you look at them, they are looking like same, right? Yes. On the right hand side, although they look like, so on the right hand side it's a window. It's a glass that's on the left hand side. Yes, it's a glass. On the left hand side it's a lead tungsten. And why we are using it? Lead tungsten. So
This is this one is we call it crystal balance. We are using it in the electromagnetic calorimeter where we are measuring the energy of the electromagnetic particles, like electromagnetic electrons, photons. When they enter, so this part, so they make scintillation. It's a light. So, but with the glass, you wouldn't be able to see any scintillation. So, since we would like to identify the particle as much as possible, we are using this lead tungsten, and each of them weigh about 1.5 kilogram, not kilometers. 1.5 kilogram.
1.5 kilogram in that
Per
size?
each, yes, in that size. I think the size is what? No, yes, this size scintillates, yeah. And 80,000 crystals in total. And each one of them weigh 1.5 kilograms.
Grow them? How do they make them?
Look at it here. Let's look how it looks like. So this is a very nice picture of the crystal balance when it is placed in the electromagnetic. I mean, this is the part.
I'm just wondering how they make this.
How they make it? Thinner.
Oh, yeah. How do they produce this crystal? Is it grown in a lab? So that,
Yeah, sure.
yeah.
I mean, lead tungsten is a special material. It's done in a special things that I cannot give you the details, unfortunately.
Right, I'm curious. I'll look at
Yeah,
it.
yes. But it's really amazing thing that, so you can see that the electromagnetic calorimeter is covered inner side of the solenoid. This is a nice picture. Yes. Now let's go to the hadronic calorimeter. So it's like a sandwich style. As you can see, this is the brass. These are the scintillators. And how many, like you see HCal, hadronic calorimeter. So we are really measuring here protons, neutrons, kaons that we can call as the hadrons. And so it has a sandwich-like, and what I like to emphasize, if you see, it has a shape of this. This is we call wedge. So these wedges are having hexagonal shape, not the hexagonal shape, well, almost a circular shape.
Okay.
Yes. And what else I can say here? Yes, these are 450,000 quart fibers embedded in this steel metal. So we are really trying to get information as much as possible by using this special material.
So what kind? So this is,
hadronic calorimeter,
and it's based.
electromagnetic calorimeter.
I see.
No, this is another story.
Yes,
This is
that's
another-
the electromagnetic.
You see,
Now this is the
this is having a
hadronic.
brass scintillators, and so well, it is designed to produce all particles, especially the hadrons.
What kind of resolution, spatial resolution does it have? And
Yes,
here
it has.
it has a lot.
It has.
Okay.
Yeah, we have also calculation for each calorimeter. For example, for the resolution of the calorimeter, the electromagnetic one, hadronic calorimeter. So we have a very almost well, let's say, resolution for each calorimeters. Okay, so I would like to take you further. So this is a selenite, actually, superconducting material.